So I'm doing question 2 from the 2006 exam, and it asks, at an intersection in Thomasville, Oregon, cars turn left at a rate of LT equals whatever cars per hour over the time interval 0 is greater than or equal to t is less than or equal to 18 hours. The graph of y equals LT is shown above, right there. So question A, it says, to the nearest whole number, find the total number of cars turning left at the intersection over the time interval 0 is greater than or equal to t is greater than or equal to 18 hours. And so from A, immediately it just pops out that it should be an integral because it says the total number of cars over a certain time interval. So it's not asking at time equals 18, it's not asking at time equals 0. It's asking for all the cars that have turned left over that whole intersection. So immediately you should know that it should be an integral. So the integral is relatively simple. It's just 0 to 18 of L to dt. And so you can just put it in on your calculator. And just like a little hint, and with the sine squared of t divided by 3, to put that in your calculator, you do parentheses sine of t divided by 3 and the whole thing squared. So just so you know how to put that in your calculator. So B, traffic engineers will consider turn restrictions when L of t is greater or equal to 150 cars per hour. Find all values of t for which L of t is greater than or equal to 150 and compute the average value for L over this time interval. Indicate units of measure. So what I first did was looked at the graph. And as you can see, I thought, okay, well, where is L of t greater than 150 cars per hour? And then this one's pretty clear. It's just in that one spot right there. It's greater than 150. And so what I had to do, so the first step is you have to find right there and right there. Sort of write the t values for when L of t becomes greater than 150. So what I did is the easiest way, I think, is I just went on my calculator. I went on my calculator and I graphed L of t equals 60 square root of t sine of t divided by 3 squared, and I made the window the same as it is on this paper. And then I graphed y equals 150. And then I just did the intersection points, and I think that's the simplest way. I mean, I'm sure there are other ways to find those 2 points, but for me that was the best way I could do it. And then once you find this point, you store it in whatever letter, and then once you find that one, you store it in whatever letter too. So I chose A and B. So the first intersection point, 12.426, which I stored in A, and then the next was 16.122, which I stored in B. And then from there, you had to do the integral from A to B of L to dt, but you can't forget to make it the average value, as it says in the question, average value, which means you have to do 1 over b minus a multiplying the integral. And the units of measure, whenever it's an integral, well, this integral finds how many cars, because it's saying how many cars. So the integral is finding this, which finds the cars, like how many cars. Like in question A, how many cars turn left? So the integral, the units of the integral are cars. But you're multiplying it by 1 over b minus a. And if you remember, b and a are both x values or t values, and the t values are measured in hours. So this is measured in cars, and the yellow portion is measured in hours, and so you're doing the green divided by the yellow, if that makes sense. Final part is C. That's really long. I'm not going to read the whole thing, but So, but the important parts is that if there's any 2-hour time interval, so if there's any integral from like 0 to 2, from 2 to 4, any 2-hour time interval throughout L of t, where the product, it's a big word, product of the total number of cars turning left and the total number of oncoming cars traveling straight is greater than 200,000. So in every 2-hour time interval, 500 oncoming cars. So 500 oncoming cars travel straight. So what I did, okay, so you have 500 is a constant throughout 0 to 18. And you need to find out when 500 times an x equals 200,000. And just simple math, 400 times 500 is 200,000. So you know that the that some integral from like x to x plus 2, so some integral between 2 hours from 2 t's must be greater than 400. And so I went back to my graph and I said, okay, what is the 2-hour time interval where L of t is the greatest? And I saw that's between between 13 and 15, right? Sort of at that point that's when L of t is the greatest. So I thought if it's not between 13 and 15, then there's really no place in L of t where the integral between 2 hours is greater than 400. So I found the integral from 13 to 15, again using my calculator, and I found it's 431.931, which is greater than 400 cars, which means a traffic signal is needed. So that's question 2. I hope you understood what I was saying. Okay.